If you look at problem number 7, you will notice that in this system of equations, both of the equations are written in standard form. When that's the case, you have to do some rearranging so that they go into slope-intercept form. When you rearrange, the first thing you need to do is add or subtract your x term. Since my x term is positive, I am going to subtract it on both sides. Your y will drop down, and you want to rewrite this as negative 5x, and since that's a positive 4, you're going to write a plus 4. Now, from here, if there is a number in front of my y, which is a 1, I could divide everything by 1, but I don't have to. So my slope is negative 5 over 1, which is down 5, right 1, and my y-intercept is 4. So I'm going to plot 4, and I'm going to count down 1, 2, 3, 4, 5, right 1, down 1, 2, 3, and I can't do it anymore. So I'm going to connect my dots. For the bottom equation, you also have to rearrange it. So I'm going to subtract 1x on both sides. Be very careful because you drop down a negative 1y equals negative 1x plus 2. And then you got to divide everything by a negative 1. So every single piece. They cancel and I get y equals. A negative divided by a negative is a positive, and 1 divided by 1 gives me 1. Positive 2 divided by negative 1 is minus 2. M is equal to 1 over 1. B is equal to negative 2. So if I plot negative 2, my slope tells me to go up 1 and right 1. And you want to continue to go up 1 and right 1. The opposite of up and to the right is down and to the left. And the dots should connect at a very nice location. If they do not connect on a grid mark, then you probably made a mistake. Okay, so this is my solution, and my solution is 1 comma negative 1. Now the last problem I'm going to do is problem number 6, and the reason I'm going to do problem number 6 is because you'll see what happens when I graph them. So notice how they're both in slope-intercept form. My slope for the top equations is negative 2 over 1, which is down 2, right 1. My y-intercept is a positive 2. So I'm going to plot 2. I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. The opposite of down and to the right is up to left 1, and you want to graph your line. The bottom equation is also in slope-intercept form, so my m is negative 2 over 1, which is down to right 1, and my b is negative 2. So I'm going to plot negative 2 and go down to right 1. Now they're not crossing in this direction, so I'm going to go up to left 1, up to left 1, up to left 1. What you notice is that these lines do not connect. I did not make a mistake. Their lines are just parallel. If you get parallel lines on a grid, parallel lines will never cross even if you continue to do rise over run forward and backwards. And since they never cross, you will have no solution. Now if I look at one more problem, I'll look at problem number 10. My first equation is written in standard form, so I need to rewrite that. So I'm going to draw my line. I have to subtract x, which is subtracting a 1x on both sides. A negative 1y drops down, and that's a negative 1x plus 2. Divide everything by negative 1, and you get y equals a negative divided by a negative is a positive, and 1 divided by 1 is 1x. 2 divided by negative 1 is negative 2. So m is 1 over 1. B is negative 2, so I'm going to plot negative 2, and I'm going to go up 1, right 1. Up 1, right 1, all the way into the corners. And then back is down 1, left 1. I'll go ahead and connect the dots. The bottom equation is x equals a number. When you have x equals a number, that's a vertical. line, you go to your x-axis, and I'm going to put a dot at -2. And vertical lines go up and down. So I'm going to use my ruler to draw a line that goes up and down. Okay. As you notice, the two lines cross where I've just highlighted. Okay. That crossing point, or that intersection, is called the solution. And the solution is -2, -4.